We are asked to solve quadratics by factoring. Solve for all values of x by factoring. So the first thing that we need to do to factor is we have to use the zero product property, which means we need to have a zero on one side of the equal sign, everything else on the other side. We can see that this is a quadratic because the highest exponent, the highest degree is 2 here. Okay, so let's go ahead and move everything to one side. I'll go ahead and start off by rewriting the problem. We should always rewrite the problem and not do the math on the problem itself. And to move everything over to one side, it looks like the left side is going to be the easier one. So I'll go ahead and get rid of the negative 3x by adding 3x to both sides. Plus 3x plus 3x. I now have x squared plus 13x plus 42. And our whole point here was to get 0 right here. So I like to put a little multiply dot above the last number that's by itself and a plus sign above the middle number next to x. So this is our diamond problem. We're looking for what numbers multiply to be 42 and add to be 13. Well, can you think of what numbers multiply to be 42 and add to be 13? Well, if you're not so sure, we can always use the Sieve of Aristothenes. The Sieve of Aristophanes says that if we go through every possible outcome, then we've covered everything that could happen here. So all the possible numbers that multiply to be 42 just go in order. 1 times 42. No combination of that makes 13. 2 times 21. Nope, no 13 there. 4 plus 2 is 6, so that is divisible by 3. 3 goes into 42 14 times. 3 and 14 don't make 13. 4, there's no 4, so I skip that. 5, no. 6. 6 times 7 is 42. It does have a combo, and then it starts over at 7. So this is every possible combination of 42. 6 and 7, though, there is a combination that makes 13. So 6 and 7. When I factor this, we always have in this case, there's a 1 in front of x squared. So in the beginning of each binomial is an x. And then we just put these numbers, the 6 and the 7, as the second part of the binomial of each one. Plus 6 and plus 7. Multiplication is commutative. It doesn't matter which order these are in. Okay, so now we're asked to solve here. The zero product property says that each one of these has to equal 0. If this is 0, multiplying the other one, then it turns into a 0 for the final answer. And same thing here. If this is a 0, we multiply it by this, and we have an outcome of 0. If it gets harder, then you'll need to break each one down. So the x plus 6 is equal to 0. We're looking for when that's true. And the x plus 7, when is that equal to 0? As you get better at these, when these are a little bit easier, you should be able to recognize that if I plug in a -6 on this one, hopefully you saw that that was one of the possible solutions. If you just plug in -6, that makes 0. Zeros it out. Feel free to test those values to plug them in. And then this one right here, can you see what it is first? It would be -7, right? And x equals -7 on that one. So these are our two solutions for this quadratic. We go ahead and put those in. -6, comma, and -7. Also, too, right here, there's some adding and subtracting cells. So if I wanted to add another answer, I'd click the plus sign. If I wanted to subtract it, I click the minus sign. Got it.